Good morning. I'm going to show you guys an example problem for forces and kind of talk my way through the steps of how to solve a problem like the ones I'm going to give you for your practice today. So let's read through the problem first. A 55 Newton box is slowing down with a constant acceleration of negative 2.5 meters per second as it slides along a rough surface. If the force of friction between the box and the floor is 13.75 newtons, what is the mass of the box in kilograms? So we're going to solve for mass in this. So let's write out some steps for ourselves first. I'm going to write them up here in white. So first I need to, I'm going to write out the values, write out my knowns with symbols. The second thing I'm going to do is I'm going to draw a diagram. This is not something you necessarily have to do because I'm not teaching y'all the diagram just because this is such a squished little unit. But if you see it, you like it, you want to try it, go for it. So I'm going to draw a diagram. The next thing I'm going to do is I'm going to write sum of the forces equations for the x and y direction. And then I'm going to do step 4 is algebra. And then my last step is plug in values. Notice that I'm only doing my values at the very last second. That's what I want y'all to do too. You plug in your values at the very end. Something I should mention is there's this x and y direction thing. That's just like you would see on a graph on a coordinate plane or anything like that. Your x direction is the same thing as your horizontal. Anything going on horizontally in your motion in a flat 2D space. And then your y is your vertical. Anything going up and down. Okay, x would be side to side, y is up and down. Let's get some color here. Ooh, that's a nice color. So let's do my first step, which is write out what I know. You'll notice that it says a 55 Newton box. That's telling me its weight. It's telling me it's Fg. So I'm going to say Fg is 55 newtons. And then it says my acceleration is negative 2.5, so I'm going to write that down. Okay. And then the other thing I know is the force of friction is going to be 13.75 newtons. And then I'm looking for mass. So mass is what? All right. Looking for math in kilograms. Next thing we're going to do is draw that diagram. So I'm just going to draw a dot to represent my box. And I know its weight points down. It's pulling it towards the center of the earth. So I'm going to say that this is Fg and that it's 55 newtons. I know that it's on a surface, so I know it's going to have a force normal, even though it didn't give us a value in the problem. And then I know that it has a force friction. And I'm pointing it to the left because that by convention is the negative direction. And I'm assuming that it was originally pushed forward, so now it's slowing down. So the box wants to move forward, but the friction is pulling it back, which is why it's slowing down. So that's why I'm going to draw it on the left. And I know that that is 13.75. Okay. I don't know what force normal is, but there's no mention in the problem of this box sinking into the ground or going up into space or anything like that. I have no reason to believe that those two forces don't cancel each other out. So if I'm going to use like a geometry kind of symbol, those two arrows are congruent. They have the exact same length, meaning the forces have the exact same value, even though they're in opposite directions. So that means my force normal is 55 newtons. It's balanced. All right, so I've done my symbols, I've drawn my diagram. Now I'm going to do sum of the forces equations. You might remember that our original formula for solving these problems is sigma F equals ma. That means all of my forces added together are equal to mass times acceleration. I'm going to split this into two different directions. So I'm going to look at just the y direction first. So I'm going to say sum of the forces in the y direction are. And now I'm going to list my forces. So in the vertical direction, I have two arrows. I have a force normal pointing up, and then I have a Fg, a gravitational force pointing down. Since it's pointing down, it's negative, so I'm going to say minus FG, okay? Now, it's not changing any motion in the vertical, so I can say also that my sum of the forces in the y direction is 0, which means that my acceleration in the y direction is 0. This acceleration over here, that's only in the x direction. So that means I can rewrite this equation and say that Fn minus Fg is 0, okay? That's my sum of the forces equation. Great. Let's do this again in the x direction. So sum of the forces in the x direction, and now I list them off. Ff is the only one, and since it's pointed to the left, that's the negative direction. So it's negative Ff, and that's going to be equal to mass times acceleration. I'm looking for mass, right? So now I have an acceleration in the x direction. I know what Ff is. So I can take this piece, I've done this, and I can do some algebra. So if I know that negative Ff is equal to max, now I can say, oh, if I divide away ax, that means I'm going to be left with mass is equal to my frictional force over ax. I have values for those. So my frictional force is 13.75, and there's a negative out front because I put one out front over here, divided by negative 2.5. When I plug that in, I'm going to get a mass of 5.5 kilograms. All right? Cool. And that solves the problem. I want to show you one more thing, just a bonus. I don't think we're going to have any problems like this, but that way you can kind of see something else that's going on in here. I didn't use any of my equations other than sum of the forces equals mass times acceleration. I didn't use the fact that friction is mu times Fn. I didn't use the fact that Fg was mass times gravity, but I want to show you some cool stuff about that. So I know that Fg is equal to mg, right? If I'm looking for mass, I already have a value, okay? So if I do Fg mg, if I divide away g, that's going to mean that m is my 55 divided by gravity. Now, here's kind of the thing I did when I wrote this problem, is I approximated gravity to be about 10. So when you do 55 divided by 10, that's how I get 5.5. That's how I came up with this problem. Something else that works out with this problem, we need some space here, is it had to work out with your friction forces so that it made physical sense too. So if I know that my force normal is 55 newtons, then I know that my force friction is mu times Fn. So if I wanted to know what mu was, I would say, oh, I'm going to divide away Fn on both sides. And this would be why you would do a sum of the forces in the y direction. It cancels, and now I've got 13.75, and I divide that by 55, and I'm going to get a value of 0.25, and that's mu. And that's how I made this problem. Just fun bonus things. You really need to only do this chunk in order to solve this problem, but I want to show you a few different options. Hopefully this has been helpful, and it's enough for you to be able to solve your problems without me today. Good luck.